a world we thought was dry. For most of human history, the moon was a face, a pale companion in the night sky marked with seas that held no water, and mountains no one had ever climbed. When the first telescopes turned toward it, they found craters and plains, but no clouds, no rivers, no shimmer of anything alive. The moon was a still photograph of a world frozen and silent. Every person who has ever lived has looked up at the same moon. It has hung above every empire and every quiet village, above every ocean and every desert, unchanging across the whole of human memory. We named its features after seas because the early astronomers, looking through their imperfect lenses, imagined that the dark, smooth plains might be with water. They were wrong. The Sea of Tranquility holds no water. The Ocean of Storms is bone dry. The names are lovely fictions, the wishful poetry of people who long to find something familiar in that distant gray world. And for a very long time that longing went unanswered. The moon kept its secrets behind its calm and ancient face, and we could only guess at what they were. And when the first people finally walked upon it in the summers between 1969 and 1972, they found exactly what the science of the day predicted: gray dust, sharp shadows, a landscape so dry that the soil clung to their suits like powdered glass. The astronauts brought home hundreds of kilograms of rock, and the rock told a consistent story. This was a dead world, a place that had never known an ocean and never would. For decades, that was the settled truth. The moon was a desert with no memory of water. It had no atmosphere to hold moisture, no clouds to carry it, no warmth in its long nights to keep it liquid. Whatever water might once have touched its surface had surely boiled away into space billions of years ago, lost forever to the vacuum. It is a strange thing how confident we can be about a world we can see every night. Then slowly the picture began to change. In the 1990s, a small American spacecraft called Clementine swept into orbit and bounced radar signals into the darkest craters near the lunar poles. Something down there reflected the signal in a way that ice would. Years later, another probe, Lunar Prospector, detected hydrogen concentrated at the poles, exactly where frozen water might hide. The evidence was indirect, easy to argue with. But it would not go away. The breakthrough came in 2009. A spacecraft was deliberately crashed into a permanently shadowed crater near the moon's south pole, and a second spacecraft flew through the plume of debris it kicked up. In that rising cloud of pulverized regolith, instruments found the unmistakable signature of water. Not a trace. Not a hint. Real water ice locked into the floor of a crater that had not seen sunlight in perhaps 2 billion years. Around the same time, other spacecraft began to notice something stranger still. Even on the sunlit parts of the moon far from the frozen poles, instruments detected faint signs of water, and a related molecule called hydroxyl clinging to the surface. Tiny amounts, easy to overlook but real. It was mysterious, and it remained so. Water, it seemed, was not only hiding in the deep, cold craters. It was scattered in small amounts across the face of the moon itself, bound up in the soil, perhaps stirred and moved by the sun. The moon, it turned out, was not bone dry after all. This was one of the most surprising discoveries of the early 21st century. And like all good discoveries, it raised far more questions than it answered. How much water was there? Was it pure ice, or was it bound up inside minerals scattered through the soil? Did it sit motionless for eons? Or did it move, drifting across the surface as the long lunar day turned to night? And there was a deeper puzzle beneath all of these. The discoveries had come piecemeal from missions that had not been designed to study water at all. They had stumbled upon it, caught its signature almost by accident in passing. No one had ever flown a spacecraft whose entire purpose, whose every instrument and every orbit was devoted to the single question of lunar water. The evidence was a scattering of glimpses, and what was needed was a long, patient stare. No one knew. The clues were real, but they were scattered and incomplete, like footprints leading into a dark room. Different instruments on different missions across different decades had each caught a glimpse of something, but no single mission had ever set out to map the water itself, to draw the picture whole, to say, here is where the water is, and here is what form it takes, and here is how it changes. And there was a tantalizing possibility threaded through all of it. Some scientists suspected that the water on the moon was not entirely still. that it might move in its own slow and ghostly way, drifting across the surface as the long lunar day turned to night. In the heat of the lunar noon, a few water molecules might lift from the soil and wander only to settle again somewhere colder, somewhere darker, gathering at last in the deep traps where the cold would hold them. If this was true, then the moon had a water cycle of its own, faint and alien, utterly unlike the rains and fair rivers of Earth, but a cycle nonetheless. A breathing of a kind almost too slow and too subtle to detect. To catch it in the act, to watch the water shift across the lunar day, would be to see something no one had ever seen. That was the gap. And into that gap a small idea began to take shape. A spacecraft modest in size and modest in cost, with one clear and patient purpose. It would go to the moon, not to land, not to plant a flag, not to dazzle the world. It would go to see the water, to trace the faint hidden cycle of moisture on a world that everyone had once believed was dry. Its name would be Lunar Trailblazer. A small idea with big ambitions. Most spacecraft are expensive. The great flagship missions, the ones that visit Saturn or photograph the outer planets, can cost billions of dollars and take a decade or more to build. They carry the weight of a nation's expectations. When they succeed, they make history, and because so much rides on them, almost nothing is left to chance. But there is another way to explore. In recent years, NASA created a quieter kind of mission. It is called Simplex, a program built around a simple, almost radical idea. Make the spacecraft small. Make it cheap. Accept that some of them will fail. And in exchange, fly far more of them far more often, reaching places that the great flagships could never justify visiting. The logic is gentle and clear-eyed. A mission capped at around $50 million cannot afford the layers of backups and redundancy that protect a billion-dollar probe. It is by design a higher-risk venture, but for that price NASA can send a small satellite to do focused, valuable science that might otherwise wait decades for a seat on a larger mission. It is a way of buying knowledge in smaller, more frequent installments. And it is a way of letting bold ideas fly before they grow old. There is a quiet honesty in this approach that is easy to admire. Most of the time when we send something precious into space, we wrap it in caution. We build it twice over with a backup for every critical part, so that if one system fails, another can take its place. This is wise, and it is expensive, and it is slow. The great missions can take 15 years from idea to launch, and by the time they fly, the scientists who first dreamed them may be near the ends of their careers. The Simplex philosophy makes a different bargain. It says, let us fly more often and accept that some will not survive. Let us be brave enough to lose a few so that we may learn many things sooner and for less. It is a philosophy that requires a certain courage and a certain peace with failure built in from the very start. Lunar Trailblazer was one of these ideas. It was selected in 2019, chosen from a field of proposals to map the water on the moon. The mission would be led not by a sprawling government center, but by a single scientist at the California Institute of Technology, a planetary researcher named Bethany Ehlman, whose career had been built on the study of water across the solar system. She would be the principal investigator, the person whose vision the spacecraft carried. She once described what drew her to the work in plain and human terms. Space exploration, she said, brings out something good in us as a society, because it asks us to band together to do something hard and challenging for the simple purpose of knowledge. That was the spirit of the thing. Not conquest, not spectacle, just the patient pursuit of understanding. Around her gathered a quiet constellation of partners. The Jet Propulsion Laboratory in Southern California would manage the mission and build one of its instruments. Caltech would lead the science and run mission operations. A major aerospace company, Lockheed Martin, would build the spacecraft itself. And from across the Atlantic, the University of Oxford and the United Kingdom Space Agency would contribute the second instrument. It was a small mission, but it reached across institutions and across oceans. The spacecraft they designed was modest in every dimension. It weighed only about 210 kilograms, roughly the mass of 2 grown adults. When its twin solar panels were folded, it was small enough to ride to space tucked beside a larger spacecraft. When those panels opened, it spanned about 3.5 meters wingtip to wingtip. People who described it reached for the same homely comparison again and again. It was about the size of a washing machine. a small box of metal and circuitry bound for the moon. Lockheed Martin built it on a new platform of their own design, a low-cost architecture meant for exactly this kind of deep space smallsat. Its propulsion and navigation systems, borrowed from a successful earlier moon mission, inheriting the quiet confidence of designs that had already worked. There was nothing reckless about it. It was careful engineering scaled down to fit a careful budget. Inside that small frame, the spacecraft carried everything it would need to survive the journey and do its work. A propulsion system fueled with hydrazine that could nudge it gently along its long path. A computer to think with. A radio to speak to Earth across the growing distance. Heaters to keep its delicate electronics from freezing in the brutal cold of space. And of course, its batteries and the solar panels that would keep them charged, drinking sunlight and turning it into the steady flow of power on which every other system depended. It was a complete little world, self-contained, built to live alone in the dark for years. And yet, for all its modesty, the ambition packed inside that small frame was enormous. This little box was meant to do something no spacecraft had ever done. It was meant to map the water of an entire world. 2 eyes for the darkness. To find water on the moon, you cannot simply look. The ice does not gleam. It does not pool in visible lakes or glint under the sun. Much of it is suspected to hide in the worst possible places, to see the floors of craters near the poles, deep pits where the sun never rises and the temperature never climbs above a brutal cold. These are the permanently shadowed regions, some of the coldest places in the entire solar system, colder even than the surface of Pluto. They have lain in darkness for billions of years. And it is precisely there in that ancient cold that water may be trapped. It is worth dwelling on these places because they are among the strangest landscapes in the solar system. The moon spins almost perfectly upright with very little tilt. Near its poles, this means that the floors of certain deep craters lie eternally below the angle of the sun. The sunlight never reaches them. Not in summer, not in any season, not once in all the long history of the moon. The rims of these craters may catch the light, but down at the bottom there is only darkness and a cold so deep it can scarcely be imagined. The temperature in some of these cold traps hovers near -240 degrees Celsius, just a few dozen degrees above the coldest possible temperature anything can reach. In a cold like that, water does not behave the way it does on Earth. It does not melt or flow or evaporate. It simply stays. Any water molecule that wanders into one of these traps, drifting across the surface or delivered by an ancient comet, becomes locked in place, frozen for as long as the darkness lasts. Which is to say, perhaps forever. These craters are like cosmic safes, sealed by shadow, holding whatever has fallen into them across billions of years. And it was into these dark frozen vaults that Lunar Trailblazer was meant to peer. So Lunar Trailblazer was given 2 ways of seeing. 2 instruments working together and each catching a different kind of light. The first was called the High-Resolution Volatiles and Minerals Moon Mapper. Its name is a mouthful, so the team called it HVM3. It was built at the Jet Propulsion Laboratory, and it was a kind of camera unlike any ordinary one. It was an imaging spectrometer, a device that splits light into its component wavelengths, the way a prism splits sunlight into a rainbow. Every material in the universe reflects and absorbs light in its own particular pattern. Water has a fingerprint. Minerals have fingerprints. And HVM3 was built to read them. Each pixel it captured was not just a point of brightness, but a tiny spectrum, a slice of light carrying the chemical signature of whatever lay beneath it. From those signatures, scientists could tell molecular water from water ice, and water ice from the hydroxyl molecules bound inside rock. The instrument could see at a resolution of about 70 meters per pixel, fine enough to map water across the lunar landscape in real detail. And here was its quiet genius. To see into a crater that the sun never touches, HVM3. It did not need direct sunlight. It could read the faint glow of light scattered down from a crater's sunlit walls onto its shadowed floor. A whisper of reflected light gathered and decoded. With it, the instrument could peer into the darkness itself and ask the question no one had been able to answer directly. Is there ice down there, and how much? Think about how remarkable that is. The floor of a permanently shadowed crater receives no direct sunlight at all, but the high rims and walls around it do catch the sun, and a tiny fraction of that light scatters downward into the pit, faint as moonlight, illuminating the darkness just barely. The human eye would see only blackness. But HVM3 was sensitive enough to gather that scattered glow and read the chemical signatures hidden within it. It was a way of seeing the unseeable, of reading the contents of a sealed vault by the dimmest reflected light. It was built to find ice in places that had never known the sun. The second instrument came from across the ocean. It was called the Lunar Thermal Mapper, or LTM, and it was built by the University of Oxford and funded by the United Kingdom Space Agency. Where HVM3 read reflected sunlight, LTM read heat. It was a thermal imager sensitive to the infrared glow that every surface gives off according to its temperature. It could map the moon's surface across a vast range of cold from about -165 degrees Celsius up toward a baking lunar noon. Temperature matters enormously for water. Ice can only survive where it is cold enough, and only certain places stay cold enough long enough. By mapping the temperature of the surface and by reading the thermal properties of the soil and rock, LTM could show where conditions allowed ice to linger and where it would vanish. It mapped the landscape's character, its silicate composition, and its physical texture paintings in the context that the water sat within. The two instruments were a partnership across an ocean and across disciplines. The spectrometer was American, built in California, sensitive to reflected light. The thermal mapper was British, built in England, sensitive to heat. Neither was complete without the other. A patch of ground might show the faint signature of water, but without knowing its temperature, you could not say whether that water would stay or flee. A patch of ground might be bitterly cold, but without reading its chemistry, you could not say whether any water was actually there. Only together did they tell the truth. It was a small and elegant example of something larger about science itself, the way understanding so often comes not from a single instrument or a single mind, but from many working in concert, each supplying what the others lack. Apart, each instrument told half a story. Together they told the whole. As they flew over the same patch of ground at the same moment, HVM3 would identify the water and the minerals, while LTM measured the temperature and the surface properties of that exact terrain. One instrument found the water. The other explained the conditions that held it. Side by side, they would produce something no mission had ever made. A picture of lunar water that captured not only where it was, but in what form, how much, and crucially, how it changed across the lunar day as the slow heat of the sun crept across the surface. That last part was the secret heart of the mission. The water on the moon may not be still. Scientists suspected it migrates, drifting like a faint frost, gathering in the cold traps by night, and stirring again as the temperature shifts. Lunar Trailblazer was designed to revisit certain sites again and again, watching for that movement, hoping to catch the lunar water cycle in the act. Not just a map, a living portrait of a world breathing its thin breath of water. Why a little water matters so much, it is fair to ask why so much effort, so much engineering and money and human care should be poured into finding a little ice in some dark craters on a world without air. The moon is not going anywhere. The water, if it is there, has waited for billions of years. Why the urgency? Why does it matter? The answers run in three directions, and each of them reaches further than the last. The first answer is practical, and it is about people. For as long as humans have dreamed of returning to the moon, the dream has been limited by a single brutal fact. Everything must be carried from Earth. Every drop of water, every breath of air, every gram of fuel must be lifted out of our planet's gravity at enormous cost. A sustained human presence on the moon, the kind that NASA's Artemis program imagines, becomes far more possible if the moon can provide some of what those explorers need. And water is the key to all of it. Water can be drunk. Split into its parts, water yields oxygen to breathe and hydrogen to burn. The same ice locked in a polar crater could one day fill a habitat with air, or fuel a rocket for the journey home, or even for journeys deeper into the solar system. A moon with usable water is not just a destination. It becomes a refueling station, a stepping stone outward. Lunar Trailblazer's maps were meant to show future missions exactly where to go, where a rover should drive, where an astronaut should walk, which dark crater might hold the resource that changes everything. There is a kind of arithmetic of weight that governs all of spaceflight, and it is merciless. To lift a single kilogram off the surface of the Earth and send it to the moon costs an enormous amount of energy and money. Every bottle of water an astronaut drinks, every breath of air, every drop of fuel would otherwise have to be hauled up out of Earth's deep gravity well at staggering expense. But if the moon already holds water in craters waiting to be tapped, then the entire equation changes. Suddenly the explorers do not have to carry everything with them. They can live in part off the land. This is the difference between visiting a place and staying there, between a footprint and a foothold. And it all turns on the simple question of whether there is water in the dark and where and how much. The principal investigator put it directly. Understanding where a rover would drive, or where an astronaut would walk to examine the deposits, she said, would benefit every future landed mission. The maps were meant to be a guide for those who would follow. The second answer is about time, and it reaches back billions of years. The ice in those permanently shadowed craters is not ordinary frost. It may be ancient beyond reckoning, sealed away in cold and darkness since the early days of the solar system. On Earth, scientists drill deep into glaciers and pull up ice cores, long cylinders of frozen time that record the composition of our planet's air across hundreds of thousands of years. The lunar ice could be something similar but far older. A frozen archive. Hidden in its chemistry are clues to where the water came from. If the ice carried traces of ammonia, it might have been delivered by comets falling from the cold outer solar system. If it carried sulfur instead, it might have been vented from the moon's own interior long ago when the young moon was still volcanically alive. To read that ice would be to read a chapter of history that no rock on Earth has preserved, because Earth, restless and living long ago, erased its own deepest records. The deputy principal investigator described it with a beautiful comparison. On Earth, she explained, an ice core drilled from a glacier can reveal the ancient history of our planet's atmosphere layer by frozen layer. The pristine ice in a permanently shadowed lunar crater could be something like that, but reaching back even further into the deep past of the solar system. It would be a record kept in the only place patient enough and cold enough to keep it. A library of frozen water undisturbed since before there was anything on Earth that could be called life. To one day sample that ice, to melt it and read its chemistry, would be to recover a story that has been lost everywhere else. And that leads to the third answer, which is the deepest of all. To understand the water on the moon is in a strange and beautiful way to understand the water on Earth. Our own planet is a world of oceans, and yet how it became one remains a genuine mystery. Where did all that water come from? Was it always here, or was it delivered falling from space over millions of years? The moon, our constant companion, formed from the same neighborhood, struck by the same comets and asteroids, bathed in the same solar wind. It is a witness that has kept better records than we have. The mission's principal investigator put it simply. Measuring the type and amount of lunar water, she said, would help reveal the lunar water cycle and offer clues to other questions, including how and when the Earth itself got its water. That is the quiet grandeur hidden inside this small mission. A washing machine-sized spacecraft sent to map a little ice was reaching toward one of the oldest questions a thinking creature can ask. Why is our world wet and alive and ours? So much depended on so small a thing. The long road to the pad building a spacecraft is an act of extraordinary patience. The idea for Lunar Trailblazer was selected in 2019, but the machine itself would not be ready to fly for years. Through the early 2020s, in clean rooms where engineers wore full-body suits to keep a single speck of dust from contaminating the instruments, the spacecraft slowly took shape. Its bus was built. Its instruments were integrated, one and then the other. The American spectrometer, and finally the British thermal mapper completing the small box of senses. It was tested the way all spacecraft are tested, which is to say, relentlessly. Shaken to simulate the violence of launch. Baked and frozen in vacuum chambers to mimic the savage temperature swings of space. Every system checked and checked again and checked once more. And all of it done under the quiet pressure that defines a small mission. There was no enormous budget to fall back on. A mission like this lives on the edge of its means, balancing ambition against the hard arithmetic of cost. The team had to be clever where they could not be lavish. The same arithmetic shaped how it would get to space. A dedicated rocket launched for one small satellite alone would have cost more than the entire mission could bear. So Lunar Trailblazer would not travel alone. It would ride as a secondary passenger on a launch already paid for by someone else. This is called a rideshare. And it is one of the great economies of modern spaceflight. You buy a seat, not the whole vehicle. Its ride was a commercial mission to the moon, a robotic lunar lander built by a company called Intuitive Machines, designated IM-2. The two spacecraft had nothing to do with one another scientifically. They simply shared a rocket, a Falcon 9, and a destination in the general direction of the moon. The lander would attempt to touch down near the lunar south pole. Lunar Trailblazer would peel away and begin its own long journey to orbit. Strangers sharing a ride into the dark, then parting ways forever. There is something quietly poignant in that arrangement seen in hindsight. Two machines built by different teams for entirely different purposes bolted to the same rocket for the sake of economy, lifting off together into the same night sky. For a few minutes they would travel as companions. Then they would separate and never meet again, each carrying its own hopes, each bound for its own fate. Neither knew anything of the other. They were simply briefly fellow travelers sharing the most dangerous moment of their lives before going their separate ways into the enormous dark. And that journey was designed to be anything but direct. A larger, more powerful mission might burn straight for the moon and arrive in days. But Lunar Trailblazer was small and its fuel was precious, every gram of it accounted for. So instead of brute force, it would use finesse. It would fly a long, looping, low-energy path through space, a trajectory that takes months instead of days. Drifting outward and curving back, borrowing tiny nudges of gravity from the Earth, the Sun, and the Moon themselves. It is a beautiful way to travel if you have the patience for it. Rather than fighting the gravity of the heavens, you let it carry you, falling along invisible currents, arriving not with a roar, but with a whisper. These low-energy paths trace enormous sweeping curves through a space far larger than the distance to the moon itself, looping out and folding back like the slow gesture of a hand. A spacecraft on such a path is not so much steered as guided, nudged, at just the right moments, so that the gravity of the worlds does the rest of the work. It is space travel as a kind of patience, a willingness to take the long way around in exchange for needing almost no fuel at all. Over roughly 4 to 6 months, the spacecraft was meant to wind its way inward, shedding speed until at last it could slip gently into orbit around the moon. From there, it would settle into a polar loop about 100 kilometers above the surface, perfectly positioned to gaze down at the poles and begin its patient survey of the water below. That was the plan. Years of work, a clever ride, a graceful path, and then a 2-year mission of quiet discovery. Everything was ready. The spacecraft sat fueled and waiting at the launch site in Florida, fastened to its adapter tucked beside its larger companion. After all the years, after all the patience, only the launch remained. The day everything went right. It happened in the dark. In the small hours of the morning on the 27th of February 2025, the engines of a Falcon 9 rocket lit beneath a clear Florida sky. The pad was the same one from which astronauts had once departed for the Moon Launch Complex 39A at the Kennedy Space Center. The rocket climbed on a column of fire, lifting 2 spacecraft toward the same gray world, brightening the night, then shrinking to a star, then gone. There is a particular feeling to a night launch. The darkness makes the fire seem brighter, the ascent more vivid. The flame climbs and climbs, casting its light across the marshes and the water, until the rocket is so high that it catches the sunlight that has not yet reached the ground, glowing against the black. And then it dwindles, becoming a moving point of light among the stars, until at last it cannot be told apart from them at all. For the people watching from the ground, there is a moment when the rocket simply becomes a star, and the spacecraft it carries pass beyond the reach of human eyes. For the people who had spent years building Lunar Trailblazer, this was the moment everything had been pointing toward. Years of design, of testing, of late nights and careful calculation, all of it riding on a few minutes of controlled violence. A launch is the most dangerous moment in a spacecraft's life. So much can go wrong. And in those first minutes, nothing did. It is worth remembering how long they had waited for this. The mission had been selected back in 2019, and like so many spacecraft, its road to the launch pad had been longer and harder than anyone first imagined. There had been schedule changes and the ordinary delays that attend any complex machine. The launch had once been hoped for years earlier. The rideshare arrangements had shifted. The patient work of building and testing had stretched on and on. For the team, this night in February 2025 was the culmination of more than half a decade of effort, the moment when the thing they had carried in their minds and their hands for so long finally became a real spacecraft flying free in the dark. After all that waiting, the launch itself lasted only minutes. That is so often the way of it. Years of preparation distilled into a few brilliant moments of fire and ascent. The rocket performed flawlessly. It carried its passengers up through the atmosphere and out beyond it, into the silence above the air. And then, about 48 minutes after liftoff, came the moment of release. Lunar Trailblazer separated cleanly from the rocket, drifting free for the first time, a small box of metal now alone in space, beginning its own life. Its companion, the lunar lander, went its separate way. The two travelers parted, each toward its own fate. Then the spacecraft did what it was supposed to do. It reached back toward Earth and spoke. Communications were established. Across the vast distance, the antennas of the Deep Space Network caught its signal, faint but clear, and the mission team heard from their creation for the first time in flight. The spacecraft was awake. It was talking. It was on its way. For a few hours, everything was right. Imagine the feeling in that control room. After all the years, after all the patience and the worry, the thing was flying. The launch had gone perfectly. The separation had gone perfectly. The first contact had gone perfectly. The little spacecraft was exactly where it should be, doing exactly what it should do, beginning the long looping journey that would carry it to the moon. There was every reason for quiet, careful joy. The kind of joy that engineers allow themselves only cautiously, because they know how much can still go wrong. This is the strange emotional weather of a mission's first hours. Relief and worry braided together, the celebration always held a little in check. A spacecraft has so many systems that must each work in sequence, far away and out of reach. The team had cleared the great hurdle of launch, but ahead lay months of careful operations. The long looping flight, the delicate maneuvers, the eventual arrival. They knew better than anyone that a perfect launch guarantees nothing about what comes after. And so they watched, and they checked the data as it arrived, and they let themselves feel just a little the joy of a beginning that had gone exactly as planned. But for now, in those first hours, the mission was alive and well. The dream that had begun in 2019 was finally truly underway. Somewhere out beyond the Earth, a small machine built to find water in the dark was sailing toward its purpose, its instruments quiet, and waiting its long road opening before it. No one knew that it would be the only good day. The morning the signal faded. The trouble came quietly, the way trouble often does in space. There was no explosion, no dramatic failure, nothing that would have looked like disaster from the outside. The spacecraft simply began to struggle, and the signs appeared first in the dry language of the data. Controllers were still receiving engineering telemetry, the steady stream of numbers that tells the spacecraft's keepers how it is feeling. And in those numbers, something was wrong. The power system was not behaving as it should. A spacecraft in space lives and dies by power. Its solar panels drink sunlight and pour that energy into its batteries. And from those batteries, everything flows: the radio, the computers, the heaters that keep its electronics from freezing, the thrusters that keep it on course. Without power, a spacecraft is not a machine. It is just an object falling. And the power was failing. The data pointed to a single terrible cause. The solar arrays were not facing the sun. The panels that should have been drinking in light were instead turned away from it into the dark. The spacecraft's batteries, with nothing to recharge them, were slowly draining away like a held breath being let go. To understand how grave this was, you have to understand how a spacecraft holds itself in space. There is no up or down out there, no ground to rest on, nothing to lean against. A spacecraft must actively control its own orientation, constantly using sensors to know which way it is facing, and small systems to turn itself as needed. Above all, it must keep its solar panels pointed toward the sun, because that is the only source of power it has. The software that manages this is among the most important on any spacecraft. It is the difference between a machine that lives and one that dies. And on Lunar Trailblazer, something in that delicate process went wrong. Rather than turning the panels toward the light, the spacecraft turned them away into the dark and could not correct itself. It is a cruel kind of failure because it is so simple. There was nothing wrong with the science instruments, nothing wrong with the radio or the spectrometer or the careful path it was meant to fly. The machine that would find water in the dark was in the end undone by something as elementary as which way it was facing. A spacecraft must hold itself correctly in space, turning its panels toward the light. and for reasons the team could not fully diagnose from afar, Lunar Trailblazer could not. There is something almost unbearably ordinary about it. Not a meteor strike, not an explosion, not some exotic catastrophe of deep space. Just a small machine that turned the wrong way, and could not turn back and slowly ran out of power because of it. The grand mission, the years of work, the careful instruments, all of it brought down by a problem as humble as a panel facing the wrong direction. Space is not always defeated by drama. Sometimes it is the smallest things, the simplest things that prove fatal in a place that forgives nothing. As the batteries weakened, the spacecraft did what spacecraft are designed to do when power runs low. It began to shut down, conserving what little energy remained, dimming itself to survive. It entered a low-power state. And in that state, with so little energy to spare, it could no longer keep up its end of the conversation. The day after launch, the signal faded. There was no final message, no warning. The numbers simply stopped arriving. The antennas on Earth listened and heard nothing. The little spacecraft that had spoken so clearly just 2 hours before had gone quiet. And without two-way communication, the team was helpless. They could not see what was happening aboard the spacecraft. They could not command it to turn its panels toward the sun. They could not fire its thrusters to keep it on its careful path to the moon. They could only listen and hope and try to understand what had gone wrong from the few clues they had managed to gather before the silence. One day, the mission that had taken 6 years to build had spoken to Earth for less than a single day before falling silent. The road to the moon, so carefully planned, so patiently laid out across months of looping flight, was already slipping away. And somewhere out beyond the Earth, turning slowly in the dark, a small machine was running out of power. Its instruments still cold, its purpose still unfulfilled, drifting away from the world it was built to study. There is a terrible quiet to that image. No alarm sounded across the void. No one out there saw it happen. The spacecraft simply dimmed like a small light going out in an enormous dark room, and kept on drifting along the path that physics had set for it. Its careful trajectory, the one that would have carried it gently to lunar orbit, depended on small course corrections fired at precise moments by its thrusters. Without power, without command, those corrections would never come. The spacecraft would simply coast, following whatever path it happened to be on. When the silence fell, carried by gravity wherever gravity chose to take it. It was no longer a spacecraft in the sense of a thing being flown. It was an object now falling freely, beyond steering, beyond reach. And on Earth, in the control room, the people who had built it could only sit with the silence and the few clues they had gathered and begin the slow work of understanding what had gone wrong, and the slower work of deciding what, if anything, could still be done. The world that listened. When a spacecraft falls silent, the easy thing would be to mourn it and move on. But that is not what happened. For months, a remarkable thing unfolded, a quiet act of collective hope stretched across the whole of the Earth. The engineers had not given up because the geometry of the situation left a sliver of possibility. The spacecraft was tumbling and drifting, but it was not falling toward destruction. It was simply adrift, its panels turned wrong, its batteries dead. And as it moved through space, the angle between the spacecraft and the sun would slowly change. The mission's project systems engineer at the Jet Propulsion Laboratory explained the slender hope. As the spacecraft drifted far beyond the moon, their models suggested its solar panels might begin to catch more sunlight, enough perhaps to trickle some charge back into the dead batteries, enough perhaps to wake the radio. It was a long shot, a bet placed on the slow turning of orbital mechanics. But it was real. The spacecraft and the sun were both moving, their relative positions shifting with each passing week as the spacecraft followed its drifting path. There would come a time, the model suggested, when the geometry might improve, when more light might fall across those wrongly turned panels. If in that window enough power flowed into the batteries, the spacecraft might stir. It might switch on its radio of its own accord. And if it did, and if anyone happened to be listening at exactly the right moment, then perhaps, just perhaps, contact could be regained. It was a chain of fragile ifs, each one uncertain, but it was not impossible. And so they waited, and they listened. They did not listen alone. This is the part of the story that is easy to miss, and the part most worth remembering. Around the world, organizations volunteered their help. Radio observatories turned their great dishes toward the empty patch of sky where the spacecraft should be. Ground-based radar stations and optical telescopes searched for the faint tumbling speck. Some who joined the effort were professionals at major institutions. Some were amateur astronomers, ordinary people with their own equipment and their own love of the sky who gave their nights to the search for a small lost machine that was not theirs and never would be. There is something quietly moving in that. A $50 million spacecraft had gone dark, and across continents, people who would never touch it, never be paid for it, never get credit for it, pointed their instruments at the dark and listened just in case. As if the whole world had leaned in close to catch a whisper. Picture it across the turning Earth. As one part of the planet rotated into night, its observatories took up the search, scanning the dark. Then, as that region turned toward dawn, the watch passed to the next and the next, the listening handed around the globe like a vigil kept in shifts. A network of antennas and telescopes, professional and amateur, government and private, scattered across many countries, all turned toward the same faint hope. None of them owed anything to this small American spacecraft. They listened anyway, because that is what people who love the sky do when something is lost in it. They turn their instruments toward the silence, and they wait. And the listening did learn something, though not what anyone hoped. By tracking the spacecraft with radar and with light, the searchers pieced together its condition. Lunar Trailblazer was in a slow spin, turning gently end over end, and it was drifting steadily outward away from the moon into the deeper dark of space. It was not dead in any violent sense. It was simply lost, tumbling quietly through the emptiness, dimmed and silent and alone. Each week the hope grew a little thinner. The favorable sunlight angle was a possibility, not a promise. And even if it came, no one could be certain the spacecraft would gather enough power to do anything at all. Even if its batteries somehow charged enough to switch on the radio, the engineers came to understand a further heartbreak. By then the spacecraft would be so far away that its signal, weak from a dying machine across an enormous gulf, might be too faint to hear, and far too faint to answer. They might catch a whisper they could never reply to. It is hard to imagine a more poignant kind of distance. A spacecraft that might against all odds wake up and call out, but whose voice by then would be so faint across so much emptiness that even if Earth heard it, Earth could not call back. A conversation that could only ever go one way if it happened at all. The team understood this, and still they kept the antennas turned, because there was nothing else to do but listen, and because the alternative was to stop, and stopping meant the end. Still they listened. Through the spring and into the summer, the world kept its quiet vigil over the small machine that could not call home. The decision to let go. There is a particular kind of courage in not giving up too early, and a particular kind of wisdom in knowing when to stop. NASA showed both in their turn. Through the spring, the recovery effort kept being extended. The deadline that might have closed the mission in the early summer was pushed back, first toward mid-June, then into early July. Each extension was justified by the same fragile hope that updated models of the spacecraft's path showed the lighting conditions might still turn favorable, that there might still be a chance for the panels to catch enough sun. And then, as July wore on, NASA granted the silent spacecraft a few more weeks still. A little more time to pick up the phone, as one report gently put it. A little more patience extended toward a machine that could not ask for it. Imagine the texture of those months for the team. The mission they had built for years had spoken to them for less than a day and then gone silent. Now their work was not to fly a spacecraft, but to wait for one, to listen at the appointed times, to check the empty data, and find it still empty week after week. There is a particular kind of grief in that slow waiting, neither hope nor mourning, but something suspended between them. Each extension was a small mercy and a small cruelty at once, keeping the door open while the odds quietly closed it. They could not let go, not while any chance were found, and so they kept showing up, kept listening, kept hoping against what they increasingly knew. It is worth pausing on that. There was no real obligation to keep trying. The spacecraft was almost certainly beyond saving. Every week of listening cost money and effort that could have gone elsewhere. And yet they kept extending the deadline, kept the antennas turned toward the empty sky, kept hoping against the lengthening odds. Not because it was efficient, because it was right. Because you do not abandon something you have poured years of care into, not while any sliver of a chance remains. But chances do run out. As the end of July approached, the favorable window was closing and the spacecraft remained silent. The models that had once offered hope now offered only the cold conclusion. The spacecraft was too far, too dim, too lost. Even if it lived, it could not be reached. And so on the 31st of July 2025, the mission was formally brought to an end. After more than 5 months of listening, NASA declared that Lunar Trailblazer would not be recovered. The vigil was over. It would have been easy to call it a failure and leave it there. A spacecraft that never reached its destination. A mission that never gathered a single measurement of the water it was built to find. By the simplest measure, it did not succeed. But the people who built it and the agency that flew it chose to understand it differently and more truly. Lunar Trailblazer was by design a high-risk mission. It was part of a program built on the deliberate acceptance that some of these small, bold ventures would fail. That was the bargain. In exchange for low cost and frequent flights, NASA accepted that not every spacecraft would come home. A leader at NASA said it plainly. The agency undertakes high-risk, high-reward missions like this one precisely in order to find new and revolutionary ways of doing science. The risk was not a flaw in the plan. The risk was the plan. And so the loss was met not with blame but with a kind of grace. The team was honored for the attempt. The failure was framed as a teacher, not a verdict. While it was not the outcome anyone had hoped for, NASA noted experiences like this one help reduce the risk for the small, low-cost spacecraft that will follow, as humanity prepares for a lasting presence on the moon. The little spacecraft had not reached the moon, but it had not been meaningless. It never could be. This way of meeting failure deserves to be noticed because it is not the way the world usually treats those who fall short. We are quick to call things failures, quick to look for someone to blame. But the people who fly spacecraft live closer to the truth of risk than most of us ever will. They know that to attempt difficult things is to invite the possibility of failure, and that you cannot have the one without the other. To punish every failure is to discourage every attempt. The wiser path, the one NASA chose here, is to honor the attempt to learn what can be learned, and to carry that knowledge forward into the next try. There is dignity in that. There is even a kind of love in it for the work and for the people who do it. It is a hard thing to let go of something you love, to stop listening, to accept that the silence is permanent, and that the small machine you built and tested and launched and named will never speak again. The team did it with dignity. They turned off the antennas. They closed the mission. And somewhere out in the dark beyond the moon, Lunar Trailblazer drifted on alone, no longer waited for. A season of reaching for the moon. It helps to remember that Lunar Trailblazer was not alone in its era, even if it ended alone in space. Its loss came during one of the most remarkable chapters in the history of lunar exploration, a time when humanity, after decades of looking elsewhere, turned its gaze back to the moon all at once. For nearly 50 years after the last Apollo astronauts left the surface, the moon was strangely neglected. We had been there, planted our flags, gathered our rocks, and moved on to other worlds. The moon became a place we had visited rather than a place we were going. But in recent years that changed. A new wave of missions began to reach toward it, launched not only by the old space powers, but by new nations, and for the first time by private companies. Robotic landers, orbiters, rovers, a whole flotilla of small machines aiming for the same gray world that Apollo had touched and left behind. The moon was crowded again with human ambition, and the moon, it turned out, had not grown any easier in our absence. This new wave of missions met with a sobering mixture of triumph and failure. Some landers touched down gently and worked beautifully. Others crashed or tipped over or fell silent, defeated by the same unforgiving environment that has always made the moon so hard to reach. For all our technology, for all that we had done it before, landing softly on another world and surviving there remained one of the most difficult things human beings attempt. The proof of this rode on the very same rocket as Lunar Trailblazer. Its companion, the commercial lander called IM-2, did reach the moon. It crossed the great distance, descended toward the surface near the South Pole, and touched down. But it did not land cleanly. The lander came to rest tipped over on its side, unable to function as intended, and its mission ended within hours of arrival. The two travelers who had shared a rocket on that February night both met their ends quickly in different ways, each defeated by a different failure. One never reached the moon at all. The other reached it only to fall, and both had been aiming in their own ways at the same part of the moon. The lunar South Pole has become the great prize of this new era. the focus of nearly everyone's ambition precisely because of the water that may hide there. The permanently shadowed craters, the cold traps, the suspected ice, all of it clusters near the poles. It is rugged, difficult terrain full of steep slopes and deep shadows, and the same darkness that makes the water so hard to study. But it is where the future of lunar exploration is expected to unfold. When astronauts return to the moon, it is toward the South Pole that they are likely to go, drawn by the same possibility of water that drew Lunar Trailblazer. The small spacecraft had been built to map exactly the region that everyone now most wants to reach. Its loss left that map a little less complete, the path forward a little less lit. There is a hard lesson in that, and a humbling one. We sometimes imagine that because Apollo succeeded more than half a century ago, the moon must be a solved problem, a place we have mastered. It is not. Each generation must relearn the difficulty for itself. The knowledge fades, the engineers who built Apollo retire, the methods must be rediscovered and rebuilt with new tools. The moon does not care how long ago we last visited. It remains exactly as hard, exactly as unforgiving, exactly as indifferent to our hopes as it has always been. Every soft landing is a genuine achievement. Every spacecraft that survives is a small victory, wrested from a place that gives nothing freely. This is the proper context for Lunar Trailblazer's loss. It was not a freak accident, not a singular embarrassment, but one note in a larger song of striving. In this season of reaching for the moon, some reached and grasped, and some reached and fell short. And that is simply the shape of what it means to attempt hard things at the edge of our ability. The failures are not separate from the successes. They are part of the same effort. The same learning, the same slow and stubborn process by which a species teaches itself again how to leave its home world and touch another. To return to the moon is to accept a certain number of losses along the way. Each one teaches. Each one is paid for and the lesson carried forward, so that those who come next may stand a little better chance. Lunar Trailblazer paid such a price. So did its companion, and the great work of returning continues undeterred, built in part on the quiet foundations of what was lost. What survives a lost mission? A spacecraft can be lost, but not everything a mission creates can be lost with it. Consider the instruments. The spectrometer built at the Jet Propulsion Laboratory and the thermal mapper built at Oxford were both real working pieces of cutting-edge technology designed and built and proven on the ground, even if they never got to look down at the moon. The knowledge that went into them does not disappear because the spacecraft fell silent. The designs exist. The engineering exists. The understanding of how to build a compact instrument that can read water's fingerprint in faint scattered light or map a frozen surface by its glow of heat. All of that knowledge survives. It will inform the instruments of future missions, the next generation of eyes sent to study the moon and the worlds beyond it. In that sense, the work was not wasted. It was a foundation laid down for others to build upon. Even the failure itself has value in a hard but genuine way. The spacecraft was lost to a power and an orientation problem. The kind of failure that once understood can be guarded against. Every future small mission that flies a little safer because of what was learned here carries a small debt to Lunar Trailblazer. This is how engineering knowledge accumulates. Not only through triumphs, but through the careful study of what went wrong. The mission's premature loss will help shape how the next small satellites are designed and how their risks are managed. A lesson paid for dearly, offered freely to those who come after. And the questions remain. That is perhaps the most important thing of all. Lunar Trailblazer was built to answer specific questions. How much water is on the moon? In what form does it hide? How does it move across the lunar day? Those questions did not die with the spacecraft. They are still there, still unanswered, still waiting in the dark craters of the lunar poles. The ice is still there, if it is there. The mystery is still whole. And because the questions matter, because they touch on the future of human exploration and the deep history of water in the solar system, they will be asked again. Other missions will come. Other instruments will look. The search for lunar water did not end on the 31st of July 2025. It only lost one of its searchers. There is a deeper meaning here too, quieter than the science and harder to measure. The mission's principal investigator once said that space exploration brings out the best in us because it gathers us together to do something hard and challenging for the sake of knowledge. Lunar Trailblazer was exactly that. A hard thing attempted by people who knew it might fail for no reward greater than understanding. And when it did fail, those same people listened for it for months, joined by strangers across the world, unwilling to let it go. Consider how many hands touched this small machine before it ever left the ground. The scientists who dreamed it and wrote the proposal. The engineers who designed its systems. The technicians who built it piece by piece in clean rooms on 2 continents. The instrument teams in California and in Oxford. The navigators who plotted its long looping path. The controllers who would have flown it. Hundreds of people across years, each contributing some small part of their skill and care to a box of metal bound for the moon. It was in the truest sense a collective act, a thing no single person could have made, brought into being by many people choosing to work together toward a goal none of them would profit from, simply because the goal was worth pursuing. That is not nothing. In fact, it may be the most human thing of all. To reach for something difficult knowing you might not grasp it. To pour years of care into a small machine and send it into the dark on a road it might never finish. To try fully and honestly, and to find dignity in the trying even when it does not end the way you hoped. The spacecraft did not reach the moon, but the people who built it reached for something, and the reaching itself was real and worthy and good. A lost mission is not an empty one. It leaves behind knowledge and lessons and unanswered questions held open for the future. And it leaves behind the quiet proof that we are the kind of creatures who will build a small box of metal, name it, and send it toward the moon to look for water in the dark simply because we wish to know. Good night, Trailblazer. Somewhere out beyond the moon it is still there. Right now, as you listen to these words, a small spacecraft is turning slowly in the dark. It does not know it has been declared lost. It does not know the antennas have gone quiet, or that the people who built it have closed its mission and let it go. It simply drifts end over end in a slow and patient spin, carried along the invisible currents of gravity into the deep emptiness beyond the moon. Its solar panels are turned the wrong way still. Its batteries are dead. Its radio is silent. Its instruments, the careful eyes built to find water in the dark, are cold and closed. And they will never open. It is so small against all that dark. A box of metal no larger than an appliance in your kitchen, lost in a space so vast that the distances cannot really be felt, only named. It will drift for a very long time, far longer than any of us will live, turning gently in the cold, growing fainter and farther with every passing year. No one is listening anymore. No one is waiting. It is alone in the truest sense, a quiet object falling forever through a quiet dark. And yet, think of what it represents. This small lost thing was built by people on a warm and crowded world, people who looked up at the moon, that pale companion we have watched for all of history, and decided they wished to understand the water hidden in its shadows. They reached out across hundreds of thousands of kilometers of emptiness with a fragile little machine and a great deal of hope. The cosmos is enormous and old and utterly indifferent to whether any spacecraft succeeds or fails, and into that indifference we reach anyway, tenderly, stubbornly, again and again. Consider the distances involved, because they are almost impossible to feel. The moon is some 380,000 kilometers from Earth. Far enough that all of human history's other journeys, every voyage across every ocean, every expedition to every pole, would fit many times over inside that single gap. And Lunar Trailblazer drifted even beyond the moon, farther still, into a deeper emptiness, where there is nothing at all. No air, no warmth, no light but the distant sun and the cold scattering of stars. It is a place so vast and so empty that the human mind cannot truly hold it. And we sent a little box of metal out into it on purpose, hoping it would find water in the dark. That impulse to reach into the vastness, despite knowing how small we are, may be the most remarkable thing about us. We are tiny creatures on a single world, and the universe pays us no special attention. It would turn exactly as it does whether we existed or not. And knowing this fully, we still build our small machines and send them outward. Still point our telescopes at the dark. Still ask our questions of a cosmos that will never answer in words. The reaching is its own answer. The trying is its own meaning. The spacecraft did not finish its journey. But the impulse that built it is not finished and never will be. We will keep looking at the moon. We will keep wondering about its water and our own, and the long shared history written into the ice of those ancient craters. Other small machines will follow. Some will succeed where this one did not. And the questions Lunar Trailblazer was built to ask will in time be answered by hands and minds that have not yet even begun their work. So let it drift. There is no sadness it can feel out there, no cold it can suffer, no loneliness it can know. It is only a machine, and its silence is peaceful. It did what it could in the single day it had. It spoke to Earth clearly and well, and then it slipped away. And it leaves behind in the people who loved it and the strangers who listened for it a small and true reminder of what we are. Creatures who reach. Creatures who try, creatures who send pieces of themselves toward the moon just to know the water it sought is still there, waiting in the dark, patient as it has been for billions of years. And the spacecraft that went to find it is out there too, turning slowly at rest in its own way. There is nothing left to do now but let it go. To release the long story of its building and its loss, the years of work and the months of listening, and to let it settle into the quiet where it belongs. The mission is over. The search will go on without it, and the small machine drifts gently into the dark, and asking nothing, troubling no one, finally, and completely at peace. So rest now. Let the day go the way the world let the spacecraft go, gently, without struggle, without holding on. The moon will still be there in the morning with its hidden water and its ancient shadows. The questions will keep, and somewhere far away a small trailblazer turns slowly in the silence and asks for nothing more than this: good night.